So today we're going to get back to graphs, and we're going to learn how to take those function tables from our last section and make a graph. So we're going to take a rule, make a table, and then graph our linear functions. So if you take a look at page 296, remember that when we're talking about functions, we're looking at two variables, and we're going to use x and y when we're graphing to help you know how to graph it using the x-coordinate and the y-coordinate. Remember that x is going to represent the domain values and y is going to represent the range values. And in that last section, we talked about those equations, those function rules. So function rules can be represented in words, which we're going to do later, in tables, which we saw in our last video, and with a graph using ordered pairs. And that's what we're going to do today. So the graph of a function is the set of ordered pairs consisting of an input, an x-coordinate, and an output, which will be a y-coordinate. And we're going to skip real world and word situations for now. And once we get comfortable with graphing, we'll pick those ideas back up. So here is a function rule. We talked about that in the last video. I'm going to go ahead and get a box here. And like I did last time, I'm going to show you there is our function rule right there. Wow, that's a big thick line there. All right, so anyway, and we're going to use this rule and we want to make a table. So remember, we're going to pick inputs, and your book tends to kind of fail a little bit here, that they're only showing positive inputs. And it's really important for the future that we also learn how to put negative inputs into a function rule when it's allowed. So in this particular case, see, they only have 0, 1, 2, and 3. I need you to get used to having at least one negative input, and I promise you there's a reason for it. So you're going to start by making a function table. You notice we are going to do 4 values, but I'm asking you that one of those 4 values be a negative. Now notice that they are picking numbers that are close to 0. They're not using inputs like 100. Could I have put 100 in for x? Sure. And your output would have been 100 plus 2, 102. But who wants to graph that point? So they're picking these values close to 0 to not only make the math easy, but to make the graphing easy. So once you've done the math and created your ordered pair, you're going to plot those. Now we are working on linear functions, so you should see that your points fall in a line, okay? So notice that in the book, I added the -1 kind of on the top of the table. And I'm going to request that you do that as well on page 297 in example 2. That's where we are right now. And add that as well so that that reminds you that we want to have at least one negative input. So now once I've picked -1, 0, 1, and 2 would have been my 4 choices, the fave 4. We're going to take each input, substitute it in for x, put it into the function machine, do the math, and write the output. So when -1 adds to 2, -1 plus 2 is a +1. So my input was a -1, my output is a 1. So I have the point -1, 1, and see I'm plotting it down here on the graph. When I put 0 into this function for x, 0 plus 2 is 2, so I'm going to plot the point 0, 2. When I put 1 in, 1 plus 2 is 3. 2 plus 2 is 4, and remember they had this one down here, 3 plus 2 is 5. And when I plot the points, they will form a line. Now you don't just leave the points. You're going to pick up, if you have a ruler, you can use that. You can use the side of your traveler. You can use the side of a pencil, and you're going to draw in the line, and you're going to put an arrow on each end. Because remember when I started, we could have put 100 in, and that 100, 102 is way like off the screen somewhere. But because this line has arrows, it's telling me that it will keep going in both directions. And this graph is the graph of the function y equals x plus 2. This table represents points on the function y equals x plus 2. And of course, this is the function rule. So we are showing this function as a rule, a table, and a graph. So realize that the term solution means that it is basically a point on the line. So you could look right now and say, yep, the point 1, 0 is a point on the line. So 1, 3, 1, 3. 1, 3 is on the line. It's a solution to this function. That's what the word solution means. Is it a point on the line? Now, you don't have to graph it to know if something is a solution. It's kind of like doing a check when we were solving equations, but this time we have to plug in -2 for x, and we would have to plug in 0 for y. And if you do the math, -2 plus 2 is 0, and since that works, that is a point on the line. So you wouldn't even have to graph it. You could just use the function rule. So let's do another example. Again, this is not in your book. So would 8, 12 be a point on the line? Is it a solution? Well, I can't see. The line doesn't stretch far enough. So the way I can do this without stretching out my graph is to substitute 8 in for x and 12 in for y, and does the math work? So my question is, does 8 plus 2 equal 12? And the answer is, no. 8 plus 2 is 10. So the point 8, 12 would not be on the line. It'd be off to the side. So is 8, 12 a solution? Substitute 8 in for x, substitute 12 in for y. If the math works, it's a thumbs up. And if it doesn't work, it's a thumbs down. And it tells you whether that point is on the line. So now we kind of have a chance here to do 2 more together. So you should have your book open to page 297. And you are going to start right now. We are going to create a function table for this got it B. First of all, I'm giving you, pause the video if you need to get your book ready, but on page 297. So again, we're going to have 4 inputs. So I'm going to put 4 inputs in the table. Notice I'm going to use the negative. I'm using my fave 4. If I use my fave 4, it will hopefully fit on the graph paper. Okay, so has everybody written those in? Okay, your next task is to substitute -1 in for x and get your output y. Substitute 0 in for x, do the math, get your y. Substitute 1 and substitute 2. And when you're done getting your y values, come back and we'll talk about graphing it. Okay, so let's see what you did. Now this middle section of the table, some of you don't even need to fill out, but basically it's showing you the math. So -1 minus 5. I want you to think that answer and I want you to check it in the calculator. -1 minus 5, you should have -6. Now 0 minus 5. So 0 is the input. What's the output? 0 minus 5 is -5. 1 minus 5 is -4, and 2 minus 5 is -3. If your inputs are in a pattern, so if you notice over here, see how they're going +1, +1, +1. So there is a pattern, then your outputs will be in a pattern. It might not be the same pattern. It happens to be adding 1 here, but just realize that it kind of helps you see if you're making a mistake. At this point in time, the next thing we're going to do is we're going to plot the point. So do you see the x of -1 and the y of -6? Can you plot -1, -6 on the graph, 0, -5, 1, -4, and 2, -3? And come back and let's see how you did. Okay, so I'm just going to put my screen up here and do this so that we can fast forward and see how the graph is. So now your points, this is a linear function. A linear function should have a graph of a line. Here are my 4 points. So there is the -1, -5, the 0, -1, -6, 0, -5, 1, -4, and 2, -3. I picked up a straight edge. It could be a ruler, the side of your traveler. I drew in the line and I put an arrow on both ends. This function rule has a graph that looks like this, and this is an example of a table that is good for that function rule. Okay, let's take a look at the other one. So I'm going to ask you right now to make your table and then graph this function. Okay, let's start with the table. I'm going to use my fave4 again, and each time I'm going to multiply by -2. So -2 times -1 would be 2. -2 times 0 is 0. -2 times 1 is -2. And -2 times 2 is -4. And now I'm going to graph those points. They should fall in a line. Now notice this time my inputs go up by 1, but my outputs are actually going down by 2, but there's still a pattern there because these are in a pattern, my outputs are in a pattern. And then if you graphed it. Now notice this time, as we come in from the left on this line, notice how you're going to have to climb up the hill? But when we come in from the left on this line, you get to go wee. Notice how the line goes down left to right here, whereas the line went up left to right here. Something interesting that we'll look at in the future. Now this one is not in your book, so I just put another one on here, a couple, so that we could just talk a couple more. When you come into class, we will also continue to do a few more. So in this case, the function rule is y equals 2 minus x. The x is behind the minus, and some people can make mistakes with that. So what I'm going to ask you to do right now is here's the fave4. Can you substitute those in and get the table, please? Okay, so let's check how you did here. So to be honest, why I did this one, or I'm going to do it with you, is because when the x is behind the minus and there's a negative, sometimes people can make a mistake with that particular input. So that would be 2 minus a -1. And if you were to change it, it would be 2 plus 1, which is 3. So I just wanted to kind of double check that with you and alert you. Now remember that these points should all fall in a line. So if you did bad math here and you went and plotted your points, the points wouldn't form a line and you know that something's up. Now you don't have this in the book, so I'm going to graph this for you. I think you're probably pretty, confident. So I'm going to plot each of those points, draw in my line, and then go ahead and put those arrows in. So remember, each input-output is a point on the line. It's a set of coordinates. Remember too, let's remember that independent variable, that independent value would be your x-coordinate. That's your horizontal. And your dependent variable or value would be your y-coordinate. So again, if you had made a mistake on that first one, then that point would have been out of alignment and you kind of would go back and check it. Always check, with your calculator. Do it in your head, check it on the calculator. So before we finish today, I'm just going to go kind of as a review of kind of what we've done. When you are graphing a function on the coordinate plane, okay, you're going to start by making a table of values. Now, if it happens to be f of x, remember that other name for the output, you can make that y so that you have the x and the y. You can name him by his other name, okay? So you can change the f of x so it makes sense to be that y. Now, once you're making your table, remember that we're going to pick values, and you get to pick any 4 you want, but the fave4 really, really helps you when graphing so that it sort of fits on the graph paper. You're going to pick 4 values, and remember, please, to include one negative. So -1, 0, 1, 2 is a great, set of numbers to pick. Now, having said that, you're going to notice with this one, I might change my input. So that's why I'm doing this one with you. Once you've picked your 4 values, you're going to substitute in, and then you're going to plot your points. You're going to draw a line and put arrows on both ends. Now, please note that as we go forward, negative numbers might not make sense. So like we might be doing something that talks about minutes. You wouldn't have negative minutes. And sometimes arrows might not be appropriate either in the real world context. But when we're just doing these algebra graphing functions, you're going to put a line and you're going to put arrows. More on this red idea, a caution down here, when we start doing the application, the word problems. So let me just talk this one through because I want to tell you that we've really leaned heavily on those fave4, the -1, 012. But sometimes you can make your life easier by picking different inputs. And so now when I'm looking at this fraction, I'm like, oh man, if I put 1 in here, that would be 2/3 plus 5, 5 and 2/3. Like I'm have to. So are there some better inputs when I'm looking at multiplying by a fraction that would make my life easier? And the answer is yes. So when I'm looking at multiplying an input times a fraction, look at that denominator, guys. Do you see that 3? My inputs are going to be chosen so that I can cancel with that 3. In other words, these numbers are going to be multiples of 3. So -3, I'm still going to use that 0. 3, 6, 9, right? So all of the numbers I'm going to put in are what are called multiples of 3. So do you see that my fave 4 changed this time? Because it's going to make the math easier here, okay? So let me show you what I mean with that first one. Now, there's the 2/3, and I'm multiplying by -3. And see how I put it over 1, just so I know who I'm multiplying by who? 2 times -3 is -6 on the top. 3 times 1 is 3. -6 divided by 3. -6 divided by 3 is -2. Add it to 5. My output is 3. So when I multiply this fraction by a multiple of 3, it doesn't give me a fraction. The 3 and the -3 basically canceled. You remember doing cross-canceling with fractions last year when you were in 7th grade. Let me just get a line here and I'll remind you of this. So this 3 basically cancels and leaving a -1 on the top. So we have a -2 over 1. So this simplifies to -2 plus 5 is 3. So what I want you to do right now is see if you can get the next 3 outputs. Okay, 2/3 times 0. I love 0. When you multiply by 0, it becomes 0. So 0 plus 5 is 5. Now, here's where this pattern might help you guys, okay? Let's see. So we're going to take 2/3 times 3. Do you see 2 times 3? 6 divided by 3 times 1, 3. 6 divided by 3 is 2. Oh, I love that. 2 plus 5 is 7. Guys, look at the pattern. If your inputs are in a pattern, your outputs are in a pattern. You already know what this one's going to be? Since this is 3 more, right? Let's just check the math. 2 times 6 is 12, divided by 3 times 1. 12 divided by 3 is 4, plus 5 is 9. So when I see that fraction, I get a little bit clever, people. And instead of just throwing the fave 4 in there, I pick multiples of the denominator so that I don't have to work with fractions and trying to plot parts of a block. So now, I don't know what happened here. Some of my parentheses just disappeared. That's kind of weird. Look at that. So let me fix that. So now we're going to plot these 4 points. And I know that you guys have confidence. Now, when I plot them, they better look like they're in a line. Otherwise, I've done some bad math or I didn't plot it right, right? They should be a linear function. And sure enough, -3, 3, 0, 5, 3, 7, and 6, 9 form a line. I draw my line and I put my arrows in. So really this slide right back here kind of reviews the whole process. So if it's an f of x, make it a y. Pick 4 values, -1, 0, 1, 2. The fave 4 are great unless there's a fraction. If there's a fraction, look at that denominator and make your fave 4 change to be multiples of that number so you don't have to try to plot parts of a block. You take your 4 values, you substitute for x, you do the math. You may use a calculator to check yourself. And then once you plot those points, they should fall on a line. If they don't, you either did bad math or bad plotting. Draw your line, put your arrows on both ends, and you have just graphed a linear function. So next time I see you, we'll do a reteach and then we'll do some practicing. And before you know it, you will be graphing linear function pros. I hope you all have a great day. See you.